In this video, I'll walk through an example of modeling with quadratic equation. And here we have a setup. I've just drawn a diagram. It's always a very good idea to start with drawing a diagram. And the problem states that we have 250 feet of fencing. 250 feet of fencing. And the barn is on one side, and there's 50 feet of the barn. And we want to know, what is the area? We want to maximize the area. Well, a square is going to be the maximum area, so we could just do guess and check, but we're going to walk this through algebraically. So we have 250 feet of fencing. So that 250 feet equals x, that's this x, plus y, plus this distance is x, plus we know that this distance is 50 feet because it is parallel and opposite side of the barn, so that's another 50 feet. Plus this side has to be y because it's going to be a rectangular, it's a square in the end, but a rectangular fenced in area. So plus y. Simplifying all that, you get 2x plus 2y equals, I'm going to subtract 50 from each side and get 200. Okay, let's hang on to that. I'll come back to that. And right now I'm going to find the area. The area as a function of x. Well, that's just x plus 50. That's this distance is x plus 50. So x plus 50 multiplied by y. Well, we have to get this y in terms of x. So I'm going to subtract 2x from each side and divide by 2, and I get y equals negative x plus 100. Okay, negative x plus 100. So I'm going to plug that in for y. And now I have this area function as x plus 50 multiplied by negative x plus 100. Multiply all that out and you get an area function of negative x squared plus 50x plus 5,000. Okay, now the question then, well, that's a function of the area in terms of x. And then another question might be find the x value that would maximize the area. Well, the maximum, if we were to graph this function a of x, the graph would look something like this. Now it's a very crude graph, but it's going to be a parabola because that's what a quadratic graph is, a parabola. So the x coordinate of that is the h of the hk. So we have formulas to find h and k, and those are the coordinates of the vertex of the parabola. So we know that h equals negative b over 2a. Well, negative b is 50, and a is negative 1. So h equals negative 50 over 2 times negative 1. So that equals 25. So the x value that gives us the largest dimensions, or the largest area, when area is maximized, the x value is 25. So at 25 feet, when x equals 25 feet. And then lastly, the dimensions. Well, the dimensions of this, we can just plug that 25 back in for x. Let's plug it into this easier one right there, and we get y equals 75. So y equals 75 feet. Now x still equals 25, but this whole dimension is 25 plus 50. So we're going to have 75 feet by 75 feet would maximize the area. Well, that makes sense because it's just going to be a square. All right, that was an example of modeling with the quadratic equation.